Hi, this is Professor V.K. Patil. I welcome you to my video classes on basic electronics. So in my last class we have discussed two applications that are nothing but the summing amplifier and a subtractor. Today we will see some two other applications. One is integrator and another is differentiator. So in integrator circuit, the output voltage is directly proportional to the integration of an input. What is this integrator? In integrator, the output voltage is directly proportional to the integration of a input. This is nothing but the integrator circuit. How to design this integrator circuit? Basic configuration what we are going to use to design the integrator is inverting amplifier. In inverting amplifier, we have a op-amp. To the inverting terminal, the input is applied, let us say V1. Non-inverting terminal is grounded and feedback is applied from output to the inverting amplifier, inverting terminal. That is nothing but negative feedback we are using in inverting amplifier. So here, if the feedback resistor is replaced by a capacitor, the circuit it becomes the integrator. Let us derive the expression for the output of this integrator. Let us assume the current flowing through this resistor is I1, the current flowing through the capacitor is I2, and the current entering into the op-amp is II. Let us say this is the node X and voltage at node X is Vx. Now by applying the KCL at the node X, apply Kirchhoff's current law at node X. What is Kirchhoff's current law? Incoming current is equal to outgoing current. So incoming current to the node X is I1. The outgoing current is I2 plus II. And we know that as the input impedance of the op-amp is very high, II, that is current entering into the op-amp, must be a 0. So therefore here II is equal to 0 as Ri is equal to infinity. So therefore equation becomes I1 is equal to I2. Now writing these current equations in terms of voltages. So I1 is nothing but the current which is moving from I1 to the node X. Hence I can write this as V1 minus Vx divided by R. We know that current flowing through the capacitor can be given as C into d by dt of voltage across capacitor. Here voltage across capacitor is nothing but Vx minus V0. Voltage across capacitor means what? Voltage in between the two terminals of the capacitor. As I2 is moving from node X to the output, so I need to consider the Vx positive and V0 negative, right? So therefore I can write V1 minus Vx divided by R. It must be equal to C into d by dt of Vx minus V0. So as Vx is equal to 0, by using the virtual ground concept, we know that the voltage at non-inverting terminal must be equal to the voltage at inverting terminal. Hence the Vx it becomes equal to the 0. Substituting Vx is equal to 0 in this equation, we will get V1 by R is equal to C into d by dt of minus V out. Right? So therefore I can write V1 by R is equal to minus C into d by dt of V0. So therefore I can write d by dt of V0 is equal to V1 divided by minus RC. Now integrating this equation on both sides, we will get integrating on both sides, we will get V0 which is equal to minus 1 divided by RC into integration of V in d omega t. And this is nothing but the expression for the output voltage of an integrator. And by careful observation, we can say that output voltage is directly proportional to the integration of an input, and such circuit is known as integrator. Thank you. In my next class, we'll discuss about the another application which is nothing but a differentiator.